All right, so we're going to start here into chapter 3. We're going to look at vectors. We're going to look at operations. We'll go to another video for projectile motion and relative motion, only because projectile motion in effect is one of the harder parts, and it's going to take a minute to explain. So let's get to it. Scalar and vectors. This really comes down to a simple discussion of what a scalar is and what a vector is, what speed is, what velocity is. Example, scalar, a speed. It's a number. If I say 90 miles an hour, I don't know where you're going, don't really care. But if I say 90 miles an hour north, it also gives you a velocity, meaning it adds that direction. Everything we will try and use in physics will be a vector, period. Moving forward. Scalar are in italics, vectors are in boldface. Your book kind of uses this over and over again. Most of the time you will use boldface numbers, and you'll see why. Okay, truthfully, if you ever use graphical representation of addition of vectors, you're going to suck. It just is horrible. One, to draw and draw an accurate diagram in scale and with the correct dimensions and angles is almost unheard of. Just doesn't happen. Short version of what you're supposed to do, looking at the picture, you're going to sit there and say, I'm going to go from this house to this business to school. And what is the resultant in C? The problem is, mathematically, I can do it in a heartbeat. Graphically, if this angle's off, if this angle's off, if this line's too long, if this one's too short, it just is a lot of problems. Ruler and protractor can solve it. We can be a lot more accurate. So, the idea, we can move these and have vectors in the simplest component of x and y. The book way, the triangle method, short, basically you're going to draw an arrow. I move from here to here, here to here, here to here. You're going to add them all up. Example, let's see if this actually play. Oh, of course it won't. The idea is this line will move to here, and we'll sit there and say, overall, where did you go? Vectors can be added in any order. In my mind, it's easier if you do all the ones to the left and then up, basically like a clock and come around. So we'll play with this. The idea is if it's going to the right, using an XY plot, it's going to the right, it's going X up, addition. If it's going to the left, it's subtraction, it's going down. Now, again, this is properties. So you can sit there and say, hey, look, I'm going to go 2 blocks over, 2 blocks up, 1 block back, and 1 block up, right? It doesn't matter how you do it. If you take this idea and go, oh, let's go 2 blocks up, 2 blocks over, 1 block back, you're still in the same place. Make sense? Doesn't matter where you do the 3 blocks. You go up 3 blocks and over 1. You just end up in the same place. So you'll see that over and over. It doesn't really matter the order we do it. Order of operations for math does. The order you do the vectors doesn't. All right, x, y vectors. Everything we need to break down is considered to be on the xy plane. It's imperative you break everything apart. You'll see why. No pun intended. In this case, you have a plane. You're looking overhead. You have the x plane, the y plane. The velocity is 300 meters per second at a 45-degree angle. You can calculate how far that plane is moving along the x and how long it is moving along the y. Draw them out graphically, use the Pythagorean theorem, rock on. However, if you don't know what the Pythagorean theorem is, a squared plus b squared equals c squared. C is going to be your longest leg. For us, you'll see x, y, n equals z, back and forth. X is replacing a, y is replacing b, z is replacing c. The tangent function. If you do not know SOHCAHTOA, take a time and Google it. We'll go through it real quick. Example, tangent is the opposite leg over the adjacent leg to get the angle on the hypotenuse. So, here's our problem. Pyramid is 130 meters tall. Width is 2.3 times 10 to the second, otherwise known as 230 meters. What is the magnitude and direction of displacement? Important information. You have a y, you have x. So now you can figure out the goal. In this case, you have your y is equal to 136. Your x is equal to 115. Obviously not drawn to scale. A squared plus b squared equals c squared. Hey, look, our triangle looks the same. I want to find theta. And our calculation. The inverse tangent of delta y over delta x. In this case, it's 49.8 degrees. Your distance, 115 squared plus 136 squared equals 178 squared. A squared plus b squared plus c squared. Now, hard part, does it make sense? Expect it to be more than 45 because the height is greater than half the width. Yes, it makes sense. So here we go. We've got a plane taking off, velocity at 95 degrees. Can we find the vertical components and the horizontal components? The answer is yes. This one's actually fairly simple. Use sine and cosine. If you don't know sine and cosine, sine of an angle, opposite over hypotenuse, saw, co, to. So, using that simple idea, wait a minute, it didn't solve it. Well, let's solve it. 95 kilometers an hour. Which one do I want to use? I'm doing 95 kilometers an hour. Do I want to use sine or cosine to find x? Adjacent leg, cosine. So for x, the velocity in x, I want to take 95 times the cosine of the angle, which in this case is 20 degrees. Velocity in the y, 95 times the sine of 20 degrees. I'll let you do the math. So now we've got to the simple idea. A single vector we can split into velocity in the x, velocity in the y. Wait a minute. Now we have two distances? Oh no, whatever will I do? Can you find the x and y of each? So here's your problem. Take a second. Might want to pause the video. All right, so we've got hiker walks 27 kilometers from her base at a 35 degrees south of east. South of east. Bring my notepad over. All right, so 35 degrees south of east. Okay. North. Never eat soggy waffles, yes? So it is south of east. South from east. So at a 30-degree, that's really hideous, 35 degrees and 27 kilometers. Gives me something, so I shouldn't be using a Sharpie. Then a 65 degrees north of east. I'm going to make a second line here. 65 degrees north of east. And she does 41 kilometers. This is 65 degrees. Can we find the mathematical solution? Yes. Sine and cosine. This first leg, so we have distance 1 in the x direction. 27 kilometers times the cosine of 35 degrees. Distance 1 in the y, 27 kilometers, sine of 35 degrees. Distance 2, x, distance 2, y. Get rid of this for a second. Click. Oh, look. Notice how they use negative 35. And I'll tell you right now, it becomes important that negative 35, because this one's below the horizontal. Helps if you guys can see that. Below the horizontal, above the horizontal. We're going two different directions. Hey, look, there's the picture. Find the x and y's. Oh, look, there they are. Now you have x total and y total. You add them together. And now you have an x and y. X, y, z, Pythagorean theorem. Are you done yet? You figured it out. If you have an x and a y, you need an angle. Inverse tangent of delta y over delta x. 29 degrees north of east. And we'll talk about that specifically as we get further and further. And we'll go from here. Take some time, pause the video, see if it makes sense, make certain you can do these problems. This is where one of the things we're going to pick up with right away. We're going to stop the video here. I'm going to actually start another video for projectile motion. Split this chapter into two sections.